Hello friends, uh, greetings for the day. This is Binod Gupta. Okay, it took some time to load this file. Fine. So we'll start from the same point. Let me first load the data file and I have loaded few of the image file for an easy expression. So as we discussed about it, we'll discuss few why do we need we have already covered that. Why do we need confusion matrix in order to judge or look at the performance of a machine learning model. So if a model says the output should be positive, so we are expecting it here to be written over here. And in case if it has been positive as per the true data, then we it goes into this quarter. Uh, Otherwise, if it has been predicted as positive, but actually in reality, the data which is provided, as I said, it is supervised learning. So under the supervised data, if the data which has if the label has been already uh, actually negative and we predicted it as positive, then it will go into the false positive quarter. So let's load the basic libraries. What I'll do is to save upon time, I'll restart and run all. So we have bank data.csv. This is the file. We'll have a quick glance through it to see what is there in this and how does this data looks like. So we can see here there are uh, uh, there are 5 columns. The first one has got result. So this is called as label in this case, and these are parameter x for us, which is actually an input. And so 5 by, we'll see this is 5 by 1001. Out of this, the first row is a label. Uh, okay, so we have 1000 records. Fine. And this is binary. So this is definitely a good example for us to work through. So since there is a result, it is uh, it is supervised learning, and then we have categorical data. We have a binary data. So this is an ideal case for ideal data to be used with our machine learning model, which I'm going to use here is decision tree. So first let me load the file through the df head. I can see that my file is loaded, but what I noticed is there is another column which has been added. So the result is the first column, which is the label. Then other 4 columns, 1, 2, 3, 4 columns are my input data. So this is input, yes is output for this record. We call this as a one record. And there is a one column which has been added, which has got not a number, a blank space there. Fine, we'll see that. We see the same thing. 1000 of records, 6 columns. And we see the column headings, number of datas, number of records into it. And if there is any non null value. Okay. Let's do a quick check upon if there is a null value. So we can see that there is no null value in all the 5 column except the last one, column number, which is in column number 5, unnamed, and it has got thousands of record, which is null. Well, let's verify if there is any duplicate entry. So there is no duplicate entry. We can see through some of it. Now here what we are doing is we are splitting the data in terms of input and output. Y will consider as a labeled output, or and X will be considered as input. So here we can see that we are considering all the rows. This is slicing, and looking for the data to be fed into it is starting from column number 1, column with the place value 1 till 5 minus 1 4. So if I go back to this, ignore this one. Starting from this is data number, data place values 1, 2, 3, and 5 minus 1 4. while y will be considered as a data frame which will accept the values from all the rows in column number 0 or column with the place value 0. And when if we'll try to print this x and y, we should be able to see that it is able to print all the four rows. Some of them are omitted for visibility while y is printed. Okay. Then we also got to see whether the data is balanced because we are going to deploy the confusion matrix. Matrix is used in terms of binary data and binary output, and wherever this output is balanced. So here we can see that our output column contains 521 no and 479 yes. So which is nearly equal distribution. So we'll call it as balanced data. We split the data into train and test model. Here I'm splitting with training data. I'm setting it to 70%. So remaining test data will be set to 30%. So having fed that model, I'm going to use a decision tree. And in decision tree, again, you have Guinea index and entropy. I'm going to use entropy model. Yeah. Entropy model in a quick word, it is a model which measures the impurity. Okay, yes, this is a good example here. So let's say there are students of this is a cluster wherein we have boys and girls mixed. So this is an impure data. So what we are going to do is filter out, segregate it till the level you get this pure data. Pure data wherein all the students should be of one type. So this is called categorization. So in case of loan, in our scenario, if the loan approver, there will be few people whose loan will be approved and few will be rejected. So once we segregate all the people whose loans have been rejected in one bucket and all the people whose loans have been approved in one bucket depending upon the previous scenario or the logic which we are using, then we once we reach to that level we call it as this last level or the decision is made. Sorry for the deviation. Now let me come back to the topic again, our code. So here we are doing is so once we have created our model, we have created dysentery classifier. Then what we do is we feed with X train and Y train data. So we are training our model saying that for X this kind of data you have to have Y train kind of output or label. So with this kind of training, once we provide to the model, we ask them to now do the prediction. You can see here entropy model. So same entropy model. Here we are saying that okay, now this time you do prediction. So this is predict function and the input parameter is the test data. So when we so whatever the output you generate, please assign this to a variable, data fragment variable, which is ypred en for entropy. So under this variable y predict with entropy model, we are generating the uh, output or we'll say predicted output. So here we can see it is in a unreadable format. Let's do a quick count. So we have got 300 records. Okay, very quickly I would like to go back and say I should have conveyed when we were breaking down the data in terms of train test split, we took 30% under test. So remaining 30% of 1000 is 300. So we can see here the test data is actually 300, while train data would have been 700. So when we are looking at the output, we'll be experimenting it through the this test data. So this is 300. Let's come back again here. And when we do a count, we can see the predicted output is also for 300 records. So there should be ideally 300 yes or no. Okay. Now here what I'm trying to do is for an easy comparison, I'm putting the truly the data which has been the label which has been provided y test, and keep it in one-to-one correlation with the data which has been the label which has been predicted. So this is an array. This is a matrix wherein the first data is for the first record. So this is the provided label. This is the predicted label. So we can see here. So every time, ideally, in ideal scenario, all this predicted versus your in the data which has and the label which has been provided should be ideally equal. So we can see here, no, 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 no. So there will be around 300 records to compare through, which will be not an eye-catchy to compare unless we, and that too, this is for just 300. What when we have 3 lakhs of data to interpret, it will be quite difficult. So we'll use some other mechanism to do that. Let's put this data directly into the confusion matrix and then avoid from counting these kind of inputs. So what we're doing is we are creating a confusion matrix and we are passing on the data, which is y test, which was actually provided with in contrast to y predict, which our machine learning model has predicted. So when we create this confusion matrix, we can see this is 2 by 2 matrix, uh, 2 columns and 2 rows. So the first one signifies here true negative, true positive. Then this is false positive and false negative. We'll look that in a quick glance here. Let me do a draw a heat map. Okay, this is something not very useful. Okay, we'll skip to this. Let's try to plot a confusion matrix with data into it. So we'll see here. What we see here is in case if it is 0, then it is negative. And actual means that y underscore test. And this side, when you have prediction onto the x-axis, you have y underscore pred, which has been predicted. So let's study this. The whole objective of this session is to talk about uh, confusion matrix. So we'll spend 2 minutes here. So what we say is when the label is in actual it was 0 or negative. No, when it was 0, ML model predicted it as 0. So with 160 record, it happened so. Similarly, when actual record ideally when it was yes or 1, I'll say positive, our ML model predicted is as positive for such records were the count of such record were 127. But on a contrast, there are few records which were actually 0, but our ML model predicted is as positive. So there are 7 such records. Similarly, there are few data which were actually positive, but our ML model predicted is as negative. So there are 6 such records. So what we can see is 160 and 127, they are sitting into true negative and true positive quarter. So this is a very good scenario, but there are few numbers which are sitting into the false positive and false negative. Falsely predicted, they will compromise our accuracy. Now, how do we trust? How do we adopt to this? Is our next question. So let's talk about this again in a better depth. Let me enlarge if I can. I hope this is clearly visible. Okay. So this is the same confusion matrix taken out. Snapshot is taken from the output there. I've written down here in the terms where 0 0 matches, it is true negative. Where 1 1 matches, it is true positive. So these two are green, so they are a ideal condition. But I've indicated two of them in red. So false positive and false negative, because if it is when it was supposed to be 0, it was predicted as 1. When it was 1, it was predicted as 0 in false negative. Now, uh, one thing which I would like to clarify, that predicted value need not be always on to the x axis. It can also be on y axis. It doesn't matter. Actual value can, in that case, would be on, will switch on to the x axis. So in both the scenario, it is the same. Even 0 and 1, it did not be preceding with 0 and then followed by 1. It can be positive or 1 and 0, doesn't matter. The only thing it matters is when we are predicting, when the system has given the data as or when the data was provided as with positive label, it should have been predicted as positive, so which is true positive. When label was provided as negative, our ML model predicted it as negative, so it was true negative. So these two are ideal scenario. In case if it was in case if the value was supposed to be negative, but we predicted it positive, as we see here, so it was falsely predicted as positive, so we say it false positive. And if data was actually positive but it was predicted as negative, so it was false negative, because ML model predicted it as negative. So logic remains the same. We may switch, we may toggle it, toggle the axis, we may toggle the values, the binary values. Does creates no impact to the logic. Now let's talk about four parameters. How do we measure the precision or the performance of a machine learning model? So this is just to check the performance. How to improve is not in the scope of this one. I'll have to have a separate call for this. This call is already longer. So here I'll limit it how to measure the performance. And there are few other criteria like feature engineering by which you can improve the accuracy or precision and recall and F1 score. So first let's concentrate or circle back to this topic of measuring performance. So accuracy. What is accuracy? Accuracy is measured in terms of predictions which have been made. Okay, so true positive by true negative by the total of all the values, all the outputs which has been identified. So in case if the system is very accurate, you'll have false positive and false negative will be 0. In that case, it will be ratio will be 1. And in that case, it will be 100% accuracy. Now, but this may not be the scenario. You might have some data which will be going into the false positive. So let's talk about another parameter performance criteria, which is precision. Here we talk about the actual positive which has been identified on a contrast to the false positive which has also been picked up. So in this case, why do we use precision? When we are highly much, when there is a penalty when in declaring the false positive. So then in such scenario, there is a penalty or there is a price to pay. So false positive should be as low as possible. When we have to focus on such things, false positive should be 0 or minimal. So when our focus is towards this, minimizing the false positive, then we go for precision. Now, uh, uh, let's take an example. The ideal scenario would be a false positive. Let's say a spam mail, a mail which has an equal chance of getting is filtered as a genuine mail or a spam mail. If a genuine mail has been flagged as an spam email, that is false alarm, it will be moved into the spamming box. That mail would be missed, and that could be critical mail. So ideally, this is not a good scenario. It can create a loss to the business. So this is one of the scenario where false positive should be very low. In this case, we'll go for precision. Let's move on to the third performance criteria, and we'll see its usage. Recall. Recall is looking at the concern of how many datas have been declared positive on a contrast to actually the value which are uh, really positive. So as you know that total number of positives are TP plus FN is also actually a positive value, but we have missed that. So we have only considered true positive. So what we missed out is the the instances where the declaration was identified as negative. Focus is, or I'll say the price or the penalty is towards having the false negative some consideration value. If the false negative value will be as close to zero, then this recall will be percentage will be 100% in that case. So when the focus is to have false negative as minimal, then we go towards then we make use of recall. So very clear extraction from here. When the focus is on towards keeping the false positive as minimal, like avoiding any mail, genuine mail to be spammed, tagged as spam mail. In such scenario, we'll focus on precision. We'll look at precision of this model. In a model wherein, let's say in terms of medical field, uh, uh, a patient who is actually, we can take an example wherein a patient who's is actually ill. Let's say there is a treatment, there is a test which is happening for a list of patients, wherein they are some of the people are cancer positive and some of them are cancer negative. So it will be a very bad scenario wherein an actual patient who is impacted, who is cancer positive, who is actually positive, has been declared as negative. So as we can see here, this FN or in this example, let's say if this is a record for a cancer patient. So six persons who are actually cancer positive, our ML model had declared them as false negative. So what will happen in case the impact is that person will assume that okay, I'm fit, I have no issues, I'm fit, treatment will be avoided for him, and that might lead to um, a severe problem later on. So it's better to have a user who is actually not cancer patient, but he has been flagged as positive. Why? Because in such case, this result might declare that person as cancer positive. But going ahead in the subsequent test, he might have to undergo through another level of test, and there it might come. There might be an outcome that he is actually not cancer positive. So that is still a better scenario rather than the previous scenario wherein a patient was ignored with because of the wrong report. So in the field of medical science, whenever you're going for a blood sample report or any other test report, most of the times you'll see the term their declaration statement saying that this could be false negative. So having spoken enough about it, about the recall, now so precision and recall they focus more on to the false positive or they stress upon false negative. Then what in case if we want to consider this too as well? So accuracy was speaking about true positive and true negative. Precision is talking only about false positive to be low. Recall is only talking about false negative to be as low as possible. Then what about considering these two? So in that case, we go for there is a fourth term which is F1 score, which is a harmony mean of 1 by precision plus 1 by recall, which if you bring it to the normalization, it will be 2 into precision into recall by precision plus recall. So I think we have spoken much about this. Let's go and work through the data. Let me increase the font size. Back to this. Okay. So while we had our confusion matrix, what we have done is we have created true positive. We have taken out all the data. Okay, we have fitted the values. So 160. Let me compare this if I can. So it is true negative 160, 127 true positive. True negative 160, true positive 127. False positive is 7 and false negative is 6. Okay. So having this data, now let's look out at the precision and accuracy. So accuracy is TP plus TN, true positive plus true negative by the whole data. Precision is true positive by the factor of true positive plus false positive. Here we are trying to minimize the FP as towards 0 so that it is equivalent to so that this ratio becomes TP plus TP becomes 1. So we can see here in this model, the precision for our data or our model is 94.76, accuracy is 95.667, recall is 95, and F1 is 95.131. Okay, let me enlarge this font. Another interesting thing which is working through this, I thought of plotting a graph because in dysentery, it is not in one step we filter all that. We do not classify all the impurities. We do not segregate in one step. So we take multiple steps. So every step, what I'm trying to do here is plot for the accuracy. So at a step one, what is accuracy? At step two, so, this is level one depth. There is no accuracy. Level 2 depth, there is no accuracy, but now accuracy is improving, and we can see after 6th level of depth the accuracy has reached to the maximum. We'll see this through the plotting the tree graph. As we can see here in this uh, decision tree graph, total number of samples are 700, depending upon upon the characteristics, depending on the feature or the columns into input. It takes number of steps to break down into to put one category of an item into another, like here in this case. Now this is a stage where it has to be pure. So to bring that, we can see here evaluate this data. This node contains the mix. We can see here down in the bottom row, it is all of one category and the other category is 0. So we can see here it is 0 and 8, 1 comma 0, 0 comma 3, 1 comma 0. Similarly, in this branch, we can see 0, 4, 1, 0. So at the last level, you'll see at least one of those values will be 0. And that's how we call it as either it is yes, only yes, or only no. So then that's how it is pure. Second thing which we would like to talk about here is this is a root node. Then this is all these are leaf nodes. Then this is called depth. So this is row one, row two, or depth two, level two depth, level three, level four depth, level five depth, and in level six depth we can see this data has been broken down, and we can see here at level 6 depth it has stopped because my level the maximum level of purity has been achieved, and same thing you can see through the graph. Level 1, level 2, level 3, there has been improvement because in level 3 we would have received this is level 1, level 2, level 3, we would have received some of the pure data like 0 by 20 125, and here you have 0 by 0 comma 1 2, so there are two nodes with pure data. So that's why at level 2 you do not see any improvement in terms of accuracy, while at level 3 you saw some improvement, and at level 6 we have seen that it has achieved the maximum purity, and after that there is nothing to improve. So that's why you can see that accuracy score has become stable after level of 6 depth. So that's how you interpret this line graph, wherein we are seeing prediction depth versus accuracy score for a given data, and using entropy as a model, a decision tree with entropy model. Okay, so this is one. Now, as I promised in the beginning, we'll have a small interactive code. So very quickly, we'll go through this code. So this is in general, what we have done above is we have trained the data, and then we have tested it, trained the data on 700 records, tested with 300 records, and we saw its output either represented in uh, either represented in terms of zeros and ones and no. And yes, I in terms of confusion matrix. Another thing which I missed to show you back when we said is true positive. Let's say 127. We say that there are true positive is 127 record. That means when I'm looking for this kind of output, we should have yes and yes. So I'll copy this, or rather I can copy this completely. I'll say I should have this kind of record. If I'll do Control C, Control F and search for this kind of records, I should have ideally 127. We'll see that. And we can see here on the search page, if you can focus onto the top right corner, there are 127 records with yes, yes. Similarly, true negative, let's account into that. Control F. All no, no, that is true negative have been highlighted, and there are 160 records. So let's look at our confusion matrix. This is 160 records. Now let's talk about false positive. So system in the record it will be yes, and we predicted it. Sorry, not me. The ML model would have predicted it as no. So it will be yes, no combination. And I remember yes was with lowercase. I'll go with yes. As you see here, with yes, no combination, it is 6 records. I wanted to see all of them colored. Okay. Yes. So there are multiple records. We'll see. So this is false negative. And we can see that false negative count is 6, as we see here in the search result. Then similarly, a reverse of this would be ideally it would have been actually negative, but our machine ML model predicted it as yes, positive. So it is false positive, and our search result shows 7 records. Let's go back and see into our confusion matrix output. I'll rather hide this output, and and we can see that this false positive when it was actually no, we our ML model depicted it as positive. It is count is 7, as you can see in the search result 7. So this is one thing which I would have been missed. Now, having seen this demo code, let's go back to the summarization. So what we'll summarize here is accuracy is true positive plus true negative by total number of instances. Where it is used in case the data set is balanced, like we saw that number of positives plus number of negatives were almost equal in terms of they were around 400 to 500 in between them out of 1000 records. Where it will be used in case of spam detection system, where number of spam and non-spam email is about the same. So there is a huge flood of spam. Accuracy would be a good way to measure. But in case we have a scenario where we'll measure precision, first of all, precision formula is true positive by true positive plus false positive. So when precision is important in scenario where the cost of false positive is very, very high. So the effort is to, that's why we have kept it in denominator so that it impacts your rating. And that's how it will, keeping it denominator will forced to tend towards zero. Where it is used? So the best example case will be email spam detection. In case if the false email, if a genuine email is tagged as a spam email, then that creates a problem. So that has to be avoided. Similarly, recall whose formula would be true positive. Okay, by false negative, the data which you are actually positive but declared as negative. Or if you read the definition, recall is crucial when missing a positive case is very costly. So, like in the case of cancer patient, which we spoke about, a disease detection, a false negative means a sick person is diagnosed as healthy, which can have a severe consequence. Okay, actually, this guy was positive, but we declared him as false negative. So this can become a problem. We cannot declare that cancer patient who is actually positive to be declared as negative. In that case, that person might ignore. He will avoid any further treatment, and the cancer might rise from one stage to another. So in such cases, then FN score when a balance is needed between the precision and recall. Okay, so when you need to find an optimal solution between precision and recall. Uh, So if you remember, we spoke about accuracy is applicable when the data is balanced. What if data is not balanced? In that case, we can go for F1 score. That is one of the aspect. Second, where it should be used in case of fraud detection. So where in fraud detection, in case false fraud detection. So for a card transaction, if it has to be identified, filtered, whether it is a fraud or not, in that case, a false positive is also a problem because a genuine transaction can be considered as fraudulent transaction, which is not a good scenario, happy scenario. Even fraud transaction should not be missed. Okay, it should not be while it is fraud, it should not be considered as negative, and it should be allowed. It should be transacted, or I'll say the fraudulent transaction is not detected. That's there is should also be a penalty for it. So here we need to consider both this precision and recall. Why it is not applicable for accuracy? Because here we are talking about positive and true negative. But what if something has gone wrong? And in that case, for something going wrong in terms of prediction, in both the case, either in case of false positive or false negative, precision and recall both has to be considered. We cannot ignore one of them. So what we do here is take the precision, take the recall, and take a harmonic mean of that. Here you can see it is 1 by precision plus 1 by recall, and that is 2 by uh, 1 by precision plus 1 by recall. So that's how, and this ends our program code. Let me go back to the PPT and need to close there as well.